Hi folks, today we're looking at trinomial form of a quadratic function or a parabola. So the last two forms that we've seen are, we saw factored form. Factored form was great for telling us the X intercepts, and it looked like a factored quadratic. The other form that we looked at was vertex form, which had this squared bracket in it and then a number tacked on to the end. That was vertex form. It was great for telling us the vertex. Those are all important features of the parabola. Though, of course, not all of them have x-intercepts. Trinomial form is the least helpful of these forms, but it is also the one that we probably most frequently run into. So we still have an ax squared. That's our leading coefficient. It still tells us the same thing as it used to. It tells us direction of opening. Okay, positive would be up, negative would be down, and it tells us steepness. The other thing that it tells us pretty easily is the y-intercept. If you imagine putting in 0 for x, all you'd be left with is this c value. So that c is the y-intercept. This is not all very helpful because what we really want to know is where's the vertex or something to locate the vertex around. And here's the trick for these. The axis of symmetry, and we could use quadratic formula to prove this, axis of symmetry is going to come from some of these parameters. It's going to be x equals negative b over 2a. So just to be clear, the b is the coefficient of x, the a is the coefficient of x squared. Once we know the axis of symmetry, and that should be in our formula booklet, that's actually told us the x-coordinate of the vertex. The x-coordinate of the vertex is negative b over 2a. Okay. And if you know the x-coordinate, then you can find the y-coordinate. The y-coordinate of the vertex is found by subbing in the x-coordinate of the vertex. Now, if you want to get fancy with this, you could say that it is, let's pick a different color here, that the y-coordinate would be f at or of negative b over 2a. But I always do this in steps anyways, so I'll find my x-coordinate and then I'll just sub in my y-coordinate. So we're going to find the vertex and sketch each of these functions. The first one says y equals x squared minus 4x plus 7. Maybe I want to have all my information here too. So what do I know? I know since it's a positive leading coefficient, it opens up. I know that it has a y-intercept of 7. And this is only for trinomial form. If you think you're going to botch it, actually throw in 0 for x and see what you get. Oh my gosh, you'll get 7, right? But we can save a step by noticing that in trinomial form, it's just that last constant on the end. All right, now we're going to hunt the vertex. So vertex, x-coordinate. Wouldn't it be nice if it were in vertex form? Then we'd just see the vertex. The x-coordinate is negative b over 2a. So for us, that's negative. B is negative 4. So negative 4 all over 2 times a. There's a secret 1 in front of that x squared, so that's 2 times 1. So the x-coordinate is at 4 over 2, or 2. Okay, maybe I'll start to write that as a point here. The vertex is at 2 something. Now we've got to find that y-coordinate. And to do that, we're just going to sub x equals 2 into the function, or the equation of the function. So we get y equals, remember the function is x squared minus 4x plus 7, so we'll get 2 squared minus 4 times 2 plus 7. Or 4 minus 8 plus 7. Okay, so that's 11 minus 8. The y-coordinate is just going to be at 3. What did we learn? We learned the vertex is at 2, 3. At this point, we can make a pretty good graph. So I've got a little grid down here. I'm going to make my vertex at 2, 3. There's the vertex. I could draw in the axis of symmetry if I wanted to. Now I'm going to put in the y-intercept. That's actually enough for me to identify this parabola. So now I'll just try and turn it into a parabola-looking thing. Now, if you had no insight, then you could find some other points by just making a table of values. But we do know that there's going to be a point that's symmetrical to this one on the other side of the vertex. Right? The axis of symmetry is happening right here at 2. So this point that I pointed out over here is going to be at the point 4, 7, just because it's 2 to the right of the vertex. So a little extra work to find the vertex, but not a whole lot. Just remember negative b over 2a. Okay, doing another example. This one also opens up because it's got a positive leading coefficient. It'll be a little steeper. It's going to have a y-intercept at negative 7. And again, if you prefer to just sub in 0 for x, you'll also find that you have a y-intercept of negative 7. We're going to go hunting for the vertex. It's going to be at some coordinates that we're going to find. And we're going to find the x-coordinate by looking at negative b over 2a. Okay, so that would be negative 12 over 2 times 3. And that gives us negative 12 over 6, or negative 2. Once we know that the x-coordinate is negative 2, we can find the y-coordinate. We'll just sub in negative 2 for x into the function. So y equals 3x squared, so that would be 3 times negative 2 squared, plus 12 times negative 2, minus 7. Okay, negative 2 squared is 4. This is minus 24. I want to be careful here. And I'm going to get negative 19. So what I've learned is that the vertex is at negative 2, negative 19. This may be a bit of a pain to sketch, but we'll do our best. I'm going to pick a scale that works for me. So for my x's, I'm going to go just in ones. If I don't label the scale, I assume it's ones. For my y's, I'm going to go in 5s. So here will be negative 20. And that way I can plot my points pretty nicely. So the vertex is at negative 2, negative 19. That's right here. Negative 2, negative 19. And the y-intercept's at negative 7. So 0, negative 7. Great. That's enough for me to draw a sketch. And even with this scale, it looks pretty steep. And it goes forever. If I wanted that other sort of symmetrical point around the vertex compared to the y-intercept, there'd be one at negative 4, negative 7. And of course, I'm just sketching these, so my scales aren't absolutely perfect, but that's a pretty darn good sketch. It's got the vertex, which is the main thing, and it's got another key point. Now, if you're watching these videos kind of like a mathematician looking for patterns, then you might be thinking, well, what's he going to throw into the last example? And a lot of the times what we'll do is we'll do an example that works well with nice numbers, and then one with slightly rougher ones, and then ones with rougher numbers still. This is not going to make it any harder, though. Okay, so right here, this still opens up. It's still steep. It's got a y-intercept of 1. We could start to graph it if we want. We're going to hunt the vertex. The vertex is at some coordinates, something, something. And the x-coordinate is just going to come from negative b over 2a. Okay, so let's throw that in. Negative b, so that'll be negative 4 all over 2 times 3. Okay, or negative 4 over 6, or negative 2/3. You probably called it. There's going to be fractions in this one. That doesn't make it unbelievably difficult. We can work this through. Okay, so I'm just going to sub in negative 2/3 into that function. 3 times negative 2/3 all squared. Now you might want to pause the video and try this yourself, or you might want to follow along with me. Totally up to you. Let's see what we get. We get 3. Negative 2/3 squared is 4/9. This one, remember 4 is just 4 over 1. So if we multiply them together, we'll get 8/3 and plus 1. Some people are going to do the same thing, multiplying this 3 by 4/9. And I'll just show what that looks like. We'll get 12/9 minus 8/3 plus 1. 12/9 actually reduces, though. 12/9 is just 4/3. And some people will go there directly from this step. All we're doing here is looking for this y coordinate. Okay, at this point we need to put all these terms together, so that means we need a common denominator. So I'll rewrite the number 1 as 3/3 and put them all together. 4 minus 8 plus 3 is negative 1/3. So what did we learn? We learned that the vertex is at negative 2/3, negative 1/3. Okay, maybe you don't love those points, but they're not going to be any harder for us to sketch, and they weren't that much rougher for us just to do the basic arithmetic to find them. So I'm going to make my scale kind of big here because I know I'm dealing with relatively small values. So here is my y-intercept at the point 0, 1. I have my vertex at negative 2/3, negative 1/3. Okay, so negative 2/3, negative 1/3, maybe about there. And I'll just make my parabola. I don't know exactly where the x-intercept is going to be, so I'm just going to do my best guess at it. And I really don't care, as long as I end up with something that looks symmetrical. Now, if you were looking for sort of the image of this point over here, notice this one's 2/3 to the right of the vertex. So this one, its image still at a y value of 1, would be 2/3 to the left, which would be at negative 4/3. If we wanted to find the x-intercepts, then we could do that without too much trouble, right? We could just set y equals to 0 and solve this either by factoring or by quadratic formula. Let's go ahead and find those x-intercepts. So I can solve this equation that I wrote up here either by factoring, so maybe you'll guess and check this thing, maybe you'll decompose it. Doesn't matter to me. But it factors pretty nicely. And if we solve each of these, we get x plus 1 equals 0, or x equals negative 1. 3x plus 1 equals 0. 3x equals negative 1, or x equals negative 1/3. Those are our two x-intercepts, and they actually look about right on our graph. Okay, so if you want to find the x-intercepts, just set y equal to 0 and solve. If you don't want to do it through factoring, maybe I'll make a little space up top. We can use the Qua Quadratic Formula, and it's negative b plus or minus the square root of b squared minus 4ac all over 2a, all over 2a. I don't need to use the discriminant because I know that it has x-intercepts at this point. Okay. So negative b would be negative of 4 plus or minus the square root of b squared. So b squared would be 16 minus 4 times a times c. So a is 3 here, c is 1. 4 times 3 times 1 is 12. Okay, let me zoom in. So that's 4 plus or minus the square root of 16 minus 12 all over 2 times a, and that would be 2 times 3. Okay. Let me just follow that through. I think that factoring is slicker here. So you get negative 4 plus or minus the square root of 4 all over 6, or negative 4 plus or minus 2 all over 6. So even if you struggle with factoring, this is still absolutely doable. Hey? The quadratic formula saves you from that pain. So negative 4 plus 2 would be negative 2 over 6, or negative 1/3. If I did the minus, I'd have negative 4, let's call this x2, negative 4 minus 2 over 6, negative 6 over 6, or negative 1. So there are some practice questions that we can do on page 33. On number 6, you're just finding the vertex. And on, you're finding the vertex, and that's it. Yeah. On number 7, you're asked to find the X-intercept. So that's what we just did. You just sub 0 for y. And in number 8, you're asked to do a bunch of those things. Find all the axis intercepts, find the coordinates of the vertex, find the axis of symmetry, which is just the x-coordinate of the vertex, and then sketch. So a few sketches, a few find the vertex, and a few find the x-intercepts. In our next lesson, we'll look at how we would convert from this trinomial form, which is frankly pretty annoying, into a more useful form like vertex form.